Very good afternoon to one and all. I, Chetana HD, Assistant Professor, Department of Computer Science and Engineering, we welcome you all for second day workshop on Network Simulator. I extend my warm welcome to our HOD, Dr. Ravi Kumar V, Professor and Head, Department of Computer Science and Engineering, VVCE, Mysuru. I welcome you, sir. I extend my warm
Thank you, ma'am.
welcome to our today's resource person, Dr. Pradeep Kumar TS, IEEE Senior Member, ACM Distinguished Speaker, and Associate Professor, Computing Science and Engineering at VIT Chennai. I welcome you, sir. Now I request Professor Swati BH, Assistant Professor, Department of Computer Science and Engineering, to introduce our today's speaker, Dr. Pradeep Kumar TS.
Good afternoon, all. It's my immense pleasure to introduce today's resource person, Dr. Pradeep Kumar T.S. Dr. Pradeep Kumar T.S. is an associate professor in School of Computing Science and Engineering at Vellore Institute of Technology, Chennai, Tamil Nadu, India. He also holds the position of Deputy Director, where he trains the faculty members on various aspects of technology and computing, learning, and productivity. He did his bachelor's in electrical and electronics engineering in College of Engineering, Burgur, and did his postgraduate engineering in embedded system technologies at College of Engineering, Anna University, and completed his PhD in sensor networks and network Internet of Things in VIT Vellore. He is involved in various research projects on e-learning for higher education, embedded systems, sensor network development, and power efficiency of sensors for various real-time applications. He developed, employed, and maintained multiple open source softwares that runs on private cloud servers that caters to more than 7,000 users of his institution. He runs a successful channel on YouTube in the name of Engineering Clinic. He authored various book chapters and more than 20 publications in peer reviewed journals and conference proceedings. He also organized two conferences in India and abroad in multidisciplinary research. He gave keynotes, workshops, guest lectures in more than 80 institutions across India in various domains in sensor networks, IoT, network simulations, and open source computing. His research interests include power modeling of sensors, energy efficiency of wireless networks, vehicular adapt networks, e-learning strategies of higher education, and open source computing. In addition, he is serving as a reviewer of various international journals of IEEE Transaction on Educational Technology, IJAIP, John Wiley, etc., and also many international conferences. Dr. Pradeep Kumar is a member of ACM, IEEE, life member of CSI India. He mentored more than 10 projects on ACM ICPC since 2012. He hosts various on campus activities of ACM chapters in Chennai. It's our we are very much fortunate to have you, sir, as our resource person. I welcome you.
Thank you,
Yeah, thank
Swati.
you.
Thank you, Swati. Now I request Dr. Pradeep Kumar TS to take over the session.
Yeah, thank you, ma'am.
Thank you, sir.
Yeah,
Thank you
good
so much,
afternoon, sir.
Pradeep. You can
Yes,
start.
yes, coach. Thank you. Yeah. Okay, so good afternoon, friends. So in this 2 3 days of session, so we will be dealing with introduction to network simulation 3. So already you might have seen network simulation 2. So now in this lecture we will be discussing about network simulation 3. So I have my operating system here. So what we'll be seeing today is I'll just write it down. So number one is some introduction to network simulator 3. So this we will be seeing as the first topic. So second will be some basic wired and wireless simulations using NS3. So this we will be seeing today. So if possible, I'll just show you the installation of it, but installation will take some 30-35 minutes. So I'll just tell you how to do that. So installation of NS3. So there is on second, and this is will be on third. And external tools. Number four will be external tools like GNU plot, trace matrix, Wireshark, NetAnim. So these softwares also we will be dealing with today. So this is the day one. So I have in day one, these are the topics in day one between 2 to 5 today. So the date is 15th October 2020. The timing will be 2 to 5 p.m. So day two tomorrow we'll be dealing with 16th October 2020. Again 2 to 5 p.m. We'll be dealing with MANET routing protocols comparison analysis, performance analysis of all these metrics for AODV, DSDV, OLSR, and BSR protocol. So this we will be seeing for the 2 days. Okay. So overall, you will be getting the glimpse of what is NS3, and I expect that. So if you are a listener, if it is a hands-on session, it will be very good. But since due to this pandemic, so I can able to do from my side, and you can just listen to this. Anyhow, this video is also been recorded. So whatever we do in the today's session, you just try out everything in your laptop or in your computer. You can try out so that when you come for tomorrow, you will have a better understanding on what will happen in day one. And when you come with tomorrow with some of the doubts, so it can be easily be rectified. So that's how the way the day one and day two the sessions will be useful to you. Okay, so let's move on to this introduction to network simulator 3. So this is the only one this slide available. So after that we don't have any slides. We have just only hands-on sessions. Okay, so okay. So now this is what the introduction to NS3 architecture. So you just see I have my URL in my domain nsnam.com, where I just have all my source codes, all my applications, even some of the projects also they're using NS3, and I have my email address is there. I also have my YouTube channel, so I'll be showing you the YouTube channel shortly at the end of the day. Okay. So NS3 introduction. The first thing is NS3. It is completely free and open source, as you see in NS2. So it is completely free and purely open source. It is mainly targeted towards research and educational use. But that is how they first targeted. But now in the industries also, they use NS3 for various test cases. So one good example is 5G networks. So 5G network is not there in India, but in some of the companies in India, they use NS3 for testing the 5G applications or 5G networking. So that's how the way NS3 play a major role in handling the network simulations. And it is not backward compatible extension of NS2. So that means that NS2 and NS3 are completely different, because NS3 is mainly deals with Python and C++, whereas NS2 deals with TCL and C++. So C++ is common between both, but in NS3 it is with Python, NS2 it is with TCL programming, and it is a new simulator. So some models of NS2 have been already been ported from NS2 to NS3. because the NS2 and NS3 are from the same vendor or from the same person. So the models which are there in NS2 have been already been ported to NS3 for instead of rewriting the entire source code. So that's how the way NS3 have been there in the domain from 2008 onwards. So almost 12 years NS3 is there, and now with most of the world universities, they migrated to NS3 for the basic networking and the research, for particularly in networks. Okay, so as I have showed you that NS3 deals with C++ and Python. So NS3 have an option saying that if you know only Python, then you can go only with Python. If you are in C++ background, you can directly go with C++. So there is no limitation that you have to use both the programming languages like that. So either C++ or Python, you can use it. So that's how the way NS3 was configured. And NS3 supports mainly on NS3 supports on Mac OS and Linux. So these are the two things it supported. So under Visual Studio and Windows, there was a beta. Windows with Visual Studio, there was a beta installation. So it was not well proven, but things are available. So in case if you are having a Mac OS, MacBook, or if you have a Linux machine, so you can install NS3 comfortably into it. In case if you have Windows, then you can use VMware. So VMware Workstation or VMware Player or VirtualBox. We call Oracle VirtualBox. So either of the three software you can use. Here Oracle VirtualBox is free, completely free. So you can install in Linux on your Oracle VirtualBox and they can make use of. But I have a complete image file that is available freely to you of 3 GB size. I will be sharing the link also. I'll share the link at the end of the session, so that you can download the operating system. You can just copy paste it and you can able to use this using Oracle VirtualBox. So you need not install anything, but directly everything will be coming together and you can able to use it. So that's the way I have this. So these are the three operating system where NS3 have a support. So now NS2, NS3, there are some basic differences. NS2 uses OTCL and C++, whereas NS3 uses only C++ with optional Python bindings. So Python is optional, but if you want to use only C++, you can use it. So for the better understanding, we will use only C++ for the rest of the 2 days. So we won't use Python, but occasionally I'll just show you how the Python codings are being implemented. In case if you are comfortable with the Python, you can move ahead with the Python rather than C++. NS2 have its own animator called network animation, NAM, whereas NS3 mostly they have the external softwares. So like new animators, visualizers, there are so many other third-party softwares. NS3 have a support. NS2 have the trace file, the usually .tr file, but NS3 have multiple trace file options. So it has packet capture, that is Wireshark. It has ASCII trace format. So there are so many trace files available. So anyway, in the next half of this session, we will be doing some experimentation so that you can understand well about NS3. Okay. So now when we come to NS3, the very fundamental thing is the coding. So most of the places we have to understand the coding. So initially, see this NS3, NS2, all these things are a full-fledged software. They give some help documentation. They have a proper documentation. So using the documentation, we can understand the source code, and we can understand how the program is written, how the software is written, what are the different APIs available. So those things we need to understand. For the understanding, NS3 have the 5 levels of knowledge. So or we call abstractions. So node, application, channel, net device, topology helpers. So these are the 5 things that is available for NS3. So what do you mean by a node? What is meant by an application? What do you mean by a channel? What do you mean by a net device? What are called topology helpers? So likewise, we have the multiple abstractions available in this NS3. Now we'll go through each and every one by one. So first thing is the node. So node, as we all know that it is a computer node. So we call it as a computer node. Node is a basic computing device of NS3. So we call a CPU as a node. We call a network element as a node. Likewise, in C++, in NS3, we have a class called as node class. So where the upper case letter indicates, upper N indicates it's a class name. So no, NODE, it's a class name. Node is like a computer which can be added with peripherals, applications, protocol stacks, and drivers to do useful work. So this only we call it as a node. So it is like a computer which can be added with peripherals, applications, protocol stacks, and drivers to do useful work. This is the node. Second thing is the application. So it's applications. So what does that application means? So NS3 applications run on NS3 nodes to drive simulations in the simulated world. So generally, these applications run on NS3 nodes to drive the simulations in the simulated world. And we have some application called as UDP Echo Client and UDP Echo Server. So echo means the echoing packets. So once a packet is echoed means, let's say if I call hello, 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 hello. So 5 times I just called only once, but the packet is echoed for around 4 times. So the same hello is been echoed for 4 times. So when any server is sending those packets, it is called as echo server. And the clients who are receiving these packets, they are called as UDP echo client. So UDP here is user datagram protocol. So UDP. So in NS3, I'll share this information as well to you. So in NS3, we have node. First thing is node. So it is a basic application class. Then we have application. In the application, we have UDP echo server application, then UDP echo client application. So UDP means user datagram protocol. So that means this user datagram protocols, when the packet is sent, the receiver could not send, the receiver won't send any acknowledgement back. So these packets are simple and effective. Okay, so contrast to this, we have TCP also. So TCP is transmission control protocol. So we have 2 things in the transport layer. One thing is UDP, another thing is the TCP. Now UDP echo client application means, so whenever the server is sending any packet, the clients doesn't bother whether they receive it or not. The server doesn't bother whether the clients are receiving the packet or not. So that's what we call as a UDP echo server application and UDP echo client application. Now in this case, there are 2 applications that I can attach to the nodes. One is a UDP client, another is a UDP server. Okay. So next thing is a channel. So channel is a communication path. Generally, we call channel as a communication path. So third thing is channel. So first thing is NS3 node. Second thing is application. Third thing is channel. The channel is usually called as communication path. So this is a communication path. It could be wired or wireless. Wireless channel. So under wired, we can call it as point to point or carrier sense multiple access. We simply call it as CSMA, or generally called as bus topology or bus CSMA. So this could be wired, could be on this wireless, could be IEEE 802.11, IEEE 802.15.x. So like this we call it as wireless or LTE or 4G, etc. So these things comes under wireless. So channel means how can I establish a channel between multiple nodes? Okay, so that's what we called as channel. So in this channel, in the real world, one can connect a computer to a network. Often the media over which data flows in these networks are called channels. So in the simulated world of NS3, one connects a node to an object representing a communication channel. Here the basic communication subnetwork abstraction is called channel and is represented in C++ by the class channel. So in C++, it is represented as a channel class. Okay. Now some of the examples, you can see CSMA channel, point-to-point channel, and Wi-Fi channel. Okay. So how we can maybe because nowadays we may not have CSMA or point-to-point in the domestic or in the home-based networking. In case if you have a Wi-Fi in your home, so what you do is you will be having a router. So in the router, you will your mobile phone or your laptop or your tablet, whatever you have, will be automatically connected to your Wi-Fi of the router. So that means between your device, between your phone to the router, there is a channel. So that is what we call as a communication path. Okay. So according to the implementation, we can have multiple channels in the network. So we'll be seeing how these channels are being useful in the networking or network simulation. Okay. So net device. So this is one thing. It's very powerful networking device. So net device means we call it as networking device. So next thing is net device. It is called as networking device. In a simulator, it's the combination of hardware and software. Software is nothing but device driver or networking driver, and hardware is the PCI or Ethernet card something. So this is what we called as this hardware. So hardware is network interface card, NIC. So not PCI, NIC card. It's called as network interface card. So this is called as NIC hardware. So in reality, so if you have a laptop with you, the laptop will be having a NIC card, and it will have a device driver, or we call as a networking driver. So the networking driver is a piece of hardware, a piece of software written by your operating system. So if you have a Windows OS, so automatically when the driver is detected, then the networking driver will be attached in plug and play, and your Windows will be detecting the hardware. But in simulator, if you want to simulate it, I need to uh, deploy both these things as a simulator, as a software. So in that case, we call the network interface card, there is NIC card, and the software together combined is called as a net device. So in NS3, the net device is there. I'll just show you what does it mean. What does that net device means? Okay. So now the net device here is, so in NS3, the net device abstraction covers both the software driver and the simulated hardware. So both the software driver and the hardware together, we call it as a NS3 net device. A net device is installed in a node in order to enable the node to communicate with other nodes in the simulation via channels. Okay. So we have to establish between multiple channels or between the multiple nodes. So we have to have the channels. Just as in a real computer, a node may be connected to more than one channel via multiple net devices. So in case it can be connected to more than one channel also, it is possible. So some of the net devices you can see CSMA net device, point-to-point net device, Wi-Fi net device, then Wi-Fi net device connected to Wi-Fi channel, point-to-point net device connected to point-to-point channel, and CSMA net device connected to CSMA channel. So this is how the way the net device is been useful. So finally, we have topology helpers. So what are called topology helpers? Topology helpers. So the topology helpers are the algorithms. So the routing. So whatever routing we do, whatever routing we will perform, so that is called the topology helpers. Okay. So in NS3, we would say that you will find nodes with attached net devices. In a large simulated network, you will need to arrange many connections between nodes, net devices, and the channels. So that's what we call it as topology helpers. Okay. So now this is what the key abstractions in a comparison. Just 1 minute, I'll drink water. Yeah. So there is the key abstractions. I just compared with what is in NS3, the node called about. In general, what is it called about? And application, channel. Then we have net device and we have topology helpers. So these things, these are the key abstractions in NS3. Okay. So now we'll come to NS3 modules. So what are the different modules? So for this, better I will just explain you directly through the help of software. Okay. 1 minute. Okay. Okay. So now I have already installed NS3. So you might be seeing here. So this is the NS3 folder. So in this NS3 folder, we have this folder name called as NS All-in-One 3.31. So this is the folder NS 3.31, and here we have NS 3.31. This is the folder, and here we have NetAnimation. So we have a software called as NetAnimation, and how the animation works. So this will be shown like this. So this is a list of animation files, and NS 3.31. So this is a folder where we will be doing all our simulations. So one example here is source. So we have SRC folder here. So in the SRC folder, we have so many modules here. So antenna, if you want to know about antenna, if you want to know about AODV protocol, if you want to know about applications, if you want to know about CSMA protocols, if you want to know about energy models, if you want to know about DSR protocol. So one example I'll just show you. I'll go to AODV protocol. So in the AODV, again, we have some list of files and folders. So here there is an examples folder. If you see examples, there is a file called as aodv.cc file. So this is an example file they have given. So if you want to simulate it, you can simulate this example file. So this is how the way the aodv.cc file is doing. And if you want to know the algorithm, how it is AODV is implemented, you can go to the model. So this is a model here. So in the model, we have files like aodv neighbor.cc and aodv neighbor.h and aodv packet.cc, aodv packet.h. So there are so many header files and cc files. So this will be showing you the major algorithms behind this aodv protocol, and it is already pre-compiled. That means the entire software is pre-compiled, so you can easily run any aodv application downloaded from internet. You can directly download. You can directly run it on NS3. So this is how the way this NS3 works. Anyway, most of these simulations we will be doing it in the terminal mode. So I need to open a terminal like this. Okay, so this is a terminal here, and from now onwards, I will just give you some commands. So what I do is, whatever command I do, I will be pasting the commands here directly, so that I will share this file. In case in future, if you are doing something, you can able to do by yourself also. Okay. Now I have installed NS3 already. So when you click LS, so we have a folder called as NS All-in-One 3.31. So when I downloaded this file, NS All-in-One -3.31 .tar.bz2. So this is the file I have downloaded and unzipped it. After unzipping it, I will be getting this folder. Okay. So this is a very simple logic. In case if I want to delete this folder again and you want to start from the beginning, it takes some 10-15 minutes time to complete the installation. Anyway, I will just leave it to you. And I have another software called as Trace Metrics. So we have another software, Trace Metrics zip file. So this I will be showing you how to use the Trace Metrics software. As of now, I have only these two softwares. One is Trace Matrix, another is NS All-in-One. Okay. So now this is the first time when I open the terminal. I'll be knowing. I'll be starting it again. So we have a terminal. Just press the command and the type terminal. This is one method. Or you can use directly Control and Alt. Press Control and Alt in your computer to open the terminal. So whichever way method you like, you just use it. So now type ls. Ls is the first command to use for NS3. So maybe I'll just use list of Linux commands to be used for NS3. So these are commands that we'll be using. I'll be showing one by one. So first command is ls. So this is the first command. So ls, this is a command. Okay. Now second command is cd. So cd is to change the directory. This is called as cd. Okay. So the syntax here is cd folder name. Okay. So this is a syntax. Maybe I'll just use dollar means that prompt, the terminal prompt is referred as dollar. Okay, so cd folder name. And now I use cd ns hyphen all-in-one hyphen 3.31. So the full name when I type it, then I am in the folder ns all-in-one 3.31. But which seems to be tedious when you type the entire folder simply by typing. It takes some time. So what I do is again when I put cd and enter, it comes to my home. This is a home directory. Okay, so where I'll just show you what is a home. Okay, now when I want to go to any folder, cd, type the first few letters and put a tab. See that automatically it auto completes. So type first few letters and put a tab. So it auto completes. So that's how the way I use it. So here, so type the first few letters and use tab for auto completing the folder names. Okay, so this is a command. So this is command number 2. Command number 3 is, so after you did it, we just go command called as pwd. So pwd means in which folder you are currently alive. So in which folder you are currently working. So this is called as pwd. So pwd is a command called as present working directory. Present working directory. So this is the command in which directory you are currently working. So the command syntax here is simply pwd. That's it. It's command. So likewise, I will be showing all the commands. So sorry. The next command is, so after I try ls, okay. So clear is a command to clear the screen. Clear the screen is a command. So the syntax here is clear. Okay. So fifth command is, so clear is done. So now what I do is next command is cd space ns tab. So automatically it completes ns hyphen 3.31. Okay. So now you type pwd. So now we are in this folder. Home Pradeep Kumar ns all-in-one 3.31 / ns 3.31. So I am in this directory now. So this is my present working directory. Okay. Now in case if I want to see what is my home address, so I can use a command called as echo $home. I can give a command called as echo $home. So home in uppercase letters. So when I type it, it will be showing you what is my home address. My home address is /home/Pradeep Kumar. This is my home address. So next command is echo command $home. This is my next command. So the syntax here is using the dollar prompt. Can use echo space $home. Okay. So similarly, echo space and $user. What is the name of the user you logged into? Then echo $shell. What is shell type you are using? Okay. So now I will be showing you echo $user. So what user I just logged in? I logged in with the username called as Pradeep Kumar. Okay. then echo dollar shell. So what is the name of the shell you are using? I am using a shell called as bin bash. So it's a bash shell. So these things are some of the variable names. Okay. So then echo dollar path. It will be showing you what is the path information. So it will be showing you how many paths are being stored in your path information. So this is for echo dollar path. So this is the next command what we were using, command number 5. So we have clearing the screen, cd, ls, then pwd, then echo. So we have so many commands we were using. Okay. So these are the commands that initially we like to know when we are working on operating on Linux machine. Okay. Okay. So now I will be going into NS3. Okay. cd, ns all in one, then ns tab. Okay. Now in case if I want to use cd space dot dot slash, if I use like this cd space dot dot, so in Linux double dot refers to previous directory. So in Linux double dot refers to previous directory, either double dot or double dot slash refers to previous directory. So it refers to previous directory. Okay. So one example here is if we are in let's say if we are in cd hello, this is fine. Suppose if this is the folder name, then next time what we'll do is hello slash this slash this slash. If this is the thing, now when I use cd space dot dot here, so then I will be getting a thing called as hello slash this slash this. So you will be getting an output like this. So the fine will be going to the previous folder is. So this is. Similarly, when I use cd dot dot slash here, then it will be now hello slash this. That's it. Now when I use again cd dot dot here, then I will be getting a folder called as hello slash. Okay. So dot dot refers or dot dot slash refers to previous directory. Okay. So this is the sixth command. So now when I use cd space dot dot, now I am just in the folder here. Now anyway, I'll just use it again. PWD. I use PWD, so I am in this folder now. Home, Pradeep Kumar, NS all-in-one 3.31 and NS hyphen 3.31. Okay, so I am in this folder now. Now cd space dot dot. When I type it, I am in this folder now. PWD. Now I am just see that I am in this folder now. So one folder, previous folder, I just go back and then I just am here. And one more time cd dot dot. When I do it here, I am in the home folder. Okay. So this is what the dot dot double dot refers to previous directory. Okay, so please keep this in mind so that these commands will be very helpful for you when you are doing so many work in Linux operating system. Okay, so since some of your students, this will be always be better if you always learn stuffs in Linux operating system rather than Windows OS. Okay, anyway, so these are some of the commands. Now we'll go to now NS3. Initially, they have so many examples, but we have to know what are the examples that they have been using. We can able to learn. So, if you want to learn some examples, so what are the examples already comes with NS3 that we would like to learn. So, those examples are given in the folder called as examples. So, CD examples, LS. Now, here we have examples on energy, error models, IPv6, real-time naming, matrix topology, routing, socket, statistics, TCP, traffic control, tutorial, UDP, UDP client server, and wireless. So there are so many example folders available. Under each and every folder, there are so many examples also available. Okay. So whichever way you like, whatever you like, you can able to do these examples. Okay. So first I will go to tutorial. So first let me go to tutorial. So tutorials are a very basic examples that you can easily understand the tutorials. So I will go with tutorials. In tutorial we have examples like this. So we have .cc, second.cc, sixth.cc, third.cc, seventh.cc, and fourth.cc, then first.cc, fifth.cc. We have Python also, first.py and third.py and second.py. So we have three Python files and we have CC files. Now to list out the files, ls start.py. Start.py means any files that have extension py. So there are three files. Example to run, first.py, second.py, and third.py. Similarly, we have ls start.cc. So then we have first.cc, then second.cc, third.cc, fourth.cc, fifth.cc, sixth and seventh.cc. So we have these files available. Okay. Now, how to run these examples? Now, these are some of the examples that is given as part of NS3. Now, how do we run these examples? Now, this is what a challenge now. How do we run this? Okay. Okay. So, I'll just give this command number. The examples are located in, I use this folder. I use this way, ns-3.31 slash example slash tutorial. This is a place where you find all the examples of a basic tutorials are available here. Okay. So whenever you just write down any command, if you want to go to the folder name, you can use this command cd ns hyphen all in one hyphen 3.31 slash ns hyphen 3.31 slash examples slash tutorial. So once you do this, you will be in the tutorial folder. Okay. So that's what I am in the tutorial folder now. So to run the .cc files in NS3, move the corresponding CC files in the scratch folder. Move the corresponding CC files in the scratch folder. So now to run the CC files, we have to move the .cc corresponding .cc files in the scratch folder. So that means we have to move it in the scratch folder. So where is the scratch folder? Scratch folder is here, ns-3.31 slash scratch. So in this folder, we have to move the files. So there are two methods to run the file. Either you can move to the scratch folder, or by default, you can directly run it. But when you are running by default, there are some issues. So that's why it's always better to move to the scratch folder. Okay. So now, if you want to move to scratch, through command, you can able to do. So using cp command. Cp is for copying the file. Cp command for copy the file. So copy source file and the destination. So I'll use the next command, seventh command. cp is the command to copy a file or a directory. How the command looks like: cp source file destination. So this is how the way we can able to write. So not cp cd, it is cp. cp source file to the destination. Or else through GUI you can do that. So let me go to GUI. So what I do is I'll go to NS 3.31. Then examples. Here we have examples. We have tutorial, and we have first.cc, second.cc, and third.cc. I'll copy all the three. These three. So three files I'll just copy: first.cc, second.cc, and third.cc. So right click and copy. Just copy. Then go back to NS 3.31. There we have a folder called as scratch. So in this scratch folder, paste it. So replace, and replace. So three files, I just pasted it. Okay. So we have copied all the three files: first.cc, second.cc, and third.cc. Okay. So copy first.cc, second.cc, and third.cc from examples tutorial folder to scratch folder. Okay, right. So now we have just copied. Now to run the .cc files, there is a command. Okay, so now to run the .cc file. Now this is a challenge now. To run the .cc files, what is the command? Okay, so the command is open a new terminal, then cd ns hyphen all-in-one hyphen 3.31 slash ns hyphen 3.31. This is the first thing. Afterwards, dot slash waf. So dot slash waf double hyphen run. Name of the folder is scratch slash first without any extension. Without any extension. So this is the command. Okay. So now dot and dot r dot slash refers to current directory. Please remember, in Linux or Windows or any OS, the dot and the dot slash, they refers to current directory, and double dot or double dot slash refers to previous directory. Please remember, single dot refers to current directory, double dot refers to previous directory. Okay. So now when you go to terminal, so let me open a new terminal again as per the logic here. So open a new terminal. So Control Alt T. I open a new terminal, then cd ns tab, then ns. So I am in this terminal now. Now we can see there is a file waf in green color. I want to run this waf file. So I want to run this waf file. So that's what this waf. So the command here is dot slash waf. Dot slash means in the current directory there is a file called as waf. Double hyphen run scratch slash first. Okay, so this is a command that to run the first file. Okay. Okay, so as of now, the simulation is compilation happened, and we got the output here. So that time 2 seconds, what happened? The time 2.003969, what happens? At 2.00737, what happens? So this way, we have a simple simulation, but we have to understand the coding, how the coding is written, on what basis the coding is written. So that we will see. Now, how to simply run a simulator? This is the command. Now let me use a simple hello simulator for testing. Double hyphen run hello hyphen simulator. If you are checking whether NS3 installed successfully or not, you will use this command dot slash waf double hyphen run hello hyphen simulator. Okay. Now if you get the output hello simulator, that means NS3 installed successfully. Okay. So NS3 installed successfully. Similarly, if I want to run the first file without any extension .cc, then I am just getting this output here. Now, what is this code about? So, how to design this code? So, this is where our logic comes. Okay. Now, we will understand how this has been, how this code has been written. So, I will open another command called as using gedit. Gedit is similar like Notepad editor. We call it as gedit. We can open any file with the gedit. Okay. So now next command here is command number 8 is open any text file in Linux. We can use text editor or simply called as gedit. The command name here is we will be using gedit file name. Okay, so this is the command name for opening the notepad file. or any text file. So gedit scratch first .cc. So this is the file I am going to open. So I will be opening this first .cc file. Okay, so this is the first .cc file that I have opened. Okay, now this we will see what are the different methods to implement this first .cc file. Just 1 minute. Okay. One minute. I'll just open an editor to show you the networking. Hello. Hello.
Hello, sir. Yes,
Yeah, there
sir.
was a power cut from there, so it's connected with my network now of 3G, 4G network.
Oh, sir, you are not audible.
Am I audible now?
Yes, sir. Yes, sir.
Okay. Okay, fine. Yeah, fine. So sorry, there was a power cut in my home, so I just connected to my mobile network. So how we can able to do this networking? So we'll understand the source code first. So after the source code, you can understand better about how NS3 can be useful for implementing. Okay. So first thing is we have the list of header files that is included. So NS3 core module.h, then NS3 network module.h, then NS3 internet module.h, and NS3 point-to-point module.h, and NS3 applications module.h. So these are the 5 modules included. Now we can see the network topologies. We have two nodes N0 and N1. So these are two nodes N0 and N1 with an IP address of 10.1.1.0. Between these two, we have a connection called as point-to-point connection. So this is a very basic understanding. See, whatever I will be showing you for this day, there are 3 examples. I will be showing you all the 3 examples. So please understand this example. So there is a fundamental of this networking. So not only NS3 you understand, you also understand about the networking concept as well. Okay. So we have two things, N0 and N1. So there are two nodes. So in these two nodes, between these two nodes, how we are going to send the packet, this is what we are going to show you. Okay. So now in NS, this is the C++ source code. So first thing is we have a namespace NS3. So how do we do usually is using namespace std. Usually we use this way, but in NS3 we use both std as well as NS3. But for time being, I will use only NS3. Okay. Now what is this first example? So this is a first script example. So now I will be showing you first script VVCE example. I will be showing you it as first VVCE example. Okay, then we have a main function. So in the main function, we have two things called as argument count and argument vector. So we have argument count and the argument vector. So argument count means, so how many argument counts and how many argument vectors are there. Okay, so this is what argument count and argument vector. Now this can be written as the command line arguments. We call this as command line arguments. Command line arguments. So we'll be showing you an example also. So how we can use a command line argument, I'll be showing you. So maybe just wait, I'll just show you in parallelly. Hash include stdio.h, then hash include stdlib.h. Okay. So then integer main integer argument count, comma character star argument vector. Okay. So then I'll use a function called return 0. We'll save this file as command, not command, example.c. I'll use a file called as example.c. Okay. So argument count and argument vector, I define two variables, integer a, comma b, comma c. Okay. So a equal to, so what I do is I use a function a2i argument vector of 0. This I will be using, and b equals a to I. I'll just tell you what is a to I. Argument vector of 1. See, actually, argument vector means this argument vector means it's a character array means it should be a string. So I want to convert the string to integer. So a to I is converting from string to integer. Similarly, A to F is converting from string to float. Okay. So argument vector of 0 and argument vector of 1. Okay. So what I do is if argument count equal to 2. So totally there are 2 argument counts, and I will be using this. Okay. So then C equals A plus B. Then printf percentage C percentage B C. C equals. Okay. So this is my simple program. So what I did here is I just written a simple program wherein argument count equal to the number of argument counts are 2. And first argument there is a 0th one will be A to I allocated to A and allocated to B, and adding C equal to A plus B. Then printf C equals. Now I'll be compiling this file. So what I do is I have example.c. So the output is VCC example.c. So no errors, a.out. So when I do a.out, it is showing C equal to 32767. No value has specified. So now the argument count here is a.out space 98 and 4. There are 2 numbers. I just showed you 2 numbers, 98 and 4. Now still it is 32767. Right. Compile it. Yeah. So you got the output here. So I'll just show you. Okay. So just compile this example. So now what I did is the total argument counts are 3. So 3 means now in this case a.out is the argument number 1. So argument for number 1, number 2, number 3. So these are 3 arguments. So if argc equal to 3, that's what it means. Argc equal to 3. Now the value of A is allocated 98. So that is the argument vector of 0, because character array always starts with 0. So argument vector of 1. So argument vector of 0 is this. Argument vector of 1 is this. Argument vector of 2 is 4. Okay. So now when I run it, C equal to 102. It's adding. So now when I use 45, then C equal to 143. So when I use 988, it will be 1033. So this is called as the command line arguments. So how many arguments I am going to supply through my command line? So that's why we call it as a command line arguments. Okay. So this is the best program that you can understand about command line arguments. So the A to I is a function which is available in stdlib. So that's why I use this A to I function. So I'll come back here. Now you can understand what is the purpose of argument count and the argument vector. Okay. So now in the command line, we have this command line argument. You are just values parsing this value argument count on the vector. Okay. Now time set resolution in nanoseconds. So the time is set in nanoseconds. NS means nanoseconds. Okay. So next thing is what is the application about? So I am going to define an application called as UDP Echo Client and UDP Echo Server application. Okay, so this is what I'm just going to do that. Now I have 2 nodes I'm going to create. So node container nodes, the name of the node container. Now this is the first entity. I showed you node is a class. Okay, now similarly, I have a node container. I just create a variable called as nodes. And nodes start create 2 nodes. So creation of 2 nodes. Okay. So I'm just creating 2 nodes here. Now next thing is the channel. The channel helper class. I'm going to create a new point-to-point helper class. That is a point-to-point channel. So I'm going to create a point-to-point channel. So point-to-point helper, point-to-point. So please see the variable name declaration. The first P is in a smaller letter, that is lowercase letters. It indicates the variable name. The first P, which is in uppercase letter, which indicates it is a class name. So point-to-point helper class is already defined in NS3. So we are simply calling the class, and this is our own variable name. So you can use P2P also. So whatever you like, you can use it. Now in this case, it is given as point-to-point. Okay. Now the device attribute and the channel attribute. So in the channel attribute, the delay is 2 milliseconds. So every 2 milliseconds, a packet will be transmitted. So that is what given in this point-to-point channel attribute. In the device attribute, it is 5 Mbps. So the bandwidth is 5 Mbps, or we call the data rate is 5 Mbps and 2 milliseconds. So usually, how do we write in the networking is, maybe I'll just show you that. Here we'll be writing like this, in the point-to-point, like this 5 comma 2. So this means that 5 means 5 Mbps and 2 means 2 milliseconds. So this way we can able to write it. Okay, so between these two lines, we got this 5 Mbps, 2 millisecond delay. Okay, so this is the delay here. Anyway, that's what this. Now node is done, channel is done. So we have seen 5 things. I'll just write it down. So we have seen nodes, channel, application, topology helper, the networks. These are the 5 entities we have seen in the beginning. So we have implemented nodes, we have implemented channel. Now we'll come to net devices. So this is on the net devices. Now what net device, that we'll see. So net device container. So we have a net device container. The name of the object is called as devices. Then device is equal to point-to-point dot install on the nodes. So what we do is, nodes is the name of the variable declared in the nodes. So this is the name of the variable declared. So we have the nodes variable declared here. So point-to-point is a channel. So this is a channel. So this point-to-point channel install on the nodes. So that means on the nodes install the net device container. So this is what it means. So install the net device container on these nodes. Okay. After installing the net device container, what we have to do? We have to set the IP address for the nodes. So for that, the nodes have to be connected to the network. So for that, we have internet stack helper stack. So we have an internet stack helper. So we want to establish internet on the particular net device. So stack dot install on the nodes. So install the internet connectivity on the particular nodes. So how many nodes we have created? We have created 2 nodes. On all the nodes, this will be installed. Then we have IP version 4 address helper address. The name of the variable is address. We are going to address using IP version 4 address. So set base address. So base address here is, now we are setting the base address, address.set base. So we have an IP address 10.1.1.0, 255.255.258.0. So let me change it to something else. Let's say 100.10.24. I'll change 300. I'll use 200. Up to 255 I can use. So 200.10.24.0. So I have my own addressing. So I'll give this. So the network mask is 255.255.255.0. Okay. So please remember, we always give the first and the last address. The first address, IP address is a network address, always ends with 0. The last address is the broadcast address, always ends with 255. So 255 won't be used as last address, and the first address will be 0 for the networking address, and last address will be 255. Okay, usually. So 0 is the networking address. Okay. Now I was just going to assign the IP network IP version 4 interface container, assigning to the devices. To the devices, I am assigning to the interfaces. Okay. So interfaces means, I'll just show you now. Just see the command if config. Can you see the command? I'm installing the software. So I think my Wi-Fi is back. I'll just yeah. Okay. So I have just installed. So I'll just use ifconfig. So once I use ifconfig, so it will be showing you. So my IP address. So 10.211.55.4. This is my IP address. It will be showing you. Okay. So this is an IP address. So for fixing this IP address, so in NS3, I will be selecting the IP. So 200.10.24.0. Okay. So then I fix this interface. So this interfaces is a name called as IF config. That means interface configuration. This is what we means IF config. Okay. Next thing is UDP Echo Server Helper. Now I am just creating my topology classes. So these are all called as topology. Sorry, this is an application. This is my application. In this application, so we are using Echo Server application and Echo Client application. So these two we are using. Sir, am I audible? Shruti ma'am, I am audible. Hello. Okay, fine.
Pradeep sir, you are audible. Please
Yeah,
continue,
yeah,
sir.
yeah.
No.
Okay, okay. No, because I couldn't get any response. That's why. Yeah, yeah. Actually, network. That's why. Okay, fine. Okay. So in this UDP Echo Server Helper, we have Echo Server. So the 9 is the port number. 9 is the port number. This. So there are 65,535 ports are available. 36 ports available in a computer on any computer. So that's why we are using this port number 9 here. So port number 9. So let me use a port number 1098. I'll use a port number of my own 1098. So now this is echo UDP echo server helper echo server. So the name of the object is echo server, and UDP echo server helper is the name of the class. Okay. So then I have application container server apps. So server apps, till what time to what time I need to start. So now you can see nodes dot get one. So this is a variable name. So we have two nodes. So I'll just show you that. We have two nodes, namely nodes dot get of 0 is one node, and nodes dot get of 1 will be other node. So we have two nodes. So this is the 0th node and the first node. So these are the two naming nodes. So now when nodes dot get of 1 means this is the server. So this node is a server node, whereas this node is a client node. So get of 0 is a client and get of 1 will be the server node. So server apps dot start. So it will be starting at 1.0 and stopping at 10.0. Okay. Now similarly we'll open the UDP echo client helper, echo client. So UDP server is here, echo server is here, now echo client is here. So port number is 1098, because the client has to know what is the server port number. So we'll be using 1098 here. Okay. Now address of 1 means the first node address it will be getting. Now how many packets? So maximum number of packets is only one. Interval is 1 second, and packet size is 1024 packet size. It's bytes, 1024 bits. So it is like this. So one packet, we'll change this number one by one. I'll just change this number. 1 second, and packet size is 1024 bytes. We'll change these values. Okay. So now the echo client is installed on nodes.get0. That means the get0 will be the client, and get1 will be the server. Okay. So now client is 2 to 10. So client arrives at between 2 to 10, whereas server is arriving at 1 to 10. So server and the client. Then simulator run and simulator destroy. Okay. 1 minute. 1 minute, I'll just show you that I want to write down something. Okay. So this is one node, this is another node. So node number 0 and node number 1. Okay. Now this is a point-to-point link. So we call it as P to P link. Okay, so this is a P2P link, and here the bandwidth is 5 Mbps and 2 millisecond delay. Okay, now this is a server node. Now this is the client. So this is the client. Okay, so the server and the client. So port number used is 1098 port number. So this is a port number, and from here to here one packet will go, and from here to here another packet will come. So this is how the way the network is going to work. Okay, so the IP address here is 200.10.24.1 and another will be 24.2, but we have given the address as 200.10.24.0. This is what we have given. So this is called as network address. Okay, so this is a network address. So this is how the way I'm going to simulate this network. Okay, so now what I'll be doing this simulation now. So okay, now cdns, then waf _run scratch first. This is the name of the file, the first dot. I don't use .cc here, directly run first. Okay, and now you can see the prediction. You can see at time 2 seconds, the client sent 1024 bytes to 200.10.24.2. So please remember, the client is sending to 200.10.24.2 port number 1098 at 2 seconds. Okay, after some time at 2.00369 seconds, the server received 1024 bytes from 200.10.24.1. Please see that this is the client and this is the server. So the client port number we didn't mention, but it is 49153. Okay. Okay, so from this client port number, the packet has been received. Then at the same time, the server sent 1024 bytes to 200.10.24.1 port number 4953, and at 2.00737 seconds, client received 1024 bytes from port number 2. So sorry, node number 2 with port number 1098. So this is a simple network, but we have sent only one packets. Okay, so now I will be changing the source code. So what I will be changing is, instead of one packet, I will give 2 packets. Instead of one packet, I will give 2 packets. Instead of 1024 bytes, I will change it to 2048 bytes. So here I will be changing 2 packets. Now I will be simply changing this. Now I will be running again. Again, you run this. Okay, so now you can see there are 2 packets. The first 4 line for packet number 1, the second 4 for packet number 2. So we have totally have 2 packets. Okay. Now in this case, you can see 2048 bytes at 2 seconds. So the simulation end at 3 seconds, whereas the simulation end at 2.00137 seconds. Okay, because for one packet and 2 packets. So if it is only one packet, the simulation ends at 2.00737 seconds. If it is at 2 packets, it is ending by 3.0001 second, almost 3 seconds. Okay, how do we see the visualization? So how can we visualize this? I want to check in an animator. Now we'll come to the concept called as NetAnim. NetAnim module in NS3. So to see the output in the animation window. Okay, so in NS2 you might be seeing, in NS2 it is called as NAM. In NS3 we call it as NetAnim. So N and A is capital. So N and A in uppercase. Okay. So how do we run this NetAnim? So first thing is include an header file called as #include, then double quotes ns3/netanim -module.h. This you have to include. Include the following line above the simulator :run function. So what line is animation interface anim of file name .xml. That's it. So we have to include a simple animation here. Okay, and I'll change the source code now. What I do is just copy this here, #include, sorry, ns3. I'll go to first.cc. So go to the beginning of the file. So add this #include this thing. Okay. The following line added by Pradeep. Okay. So first I added the network animation module to be included. Next thing is, this is a simulator run function. So this is a simulator run function. Above this, you need to add animation interface without any gap. Animation interface. It's the name of the class. Animation interface anim first.xml. I'll name the file as first.xml. So I name it as first.xml. So there are two concepts. If you want to know if you want to set the location of your nodes, you can set the location, or else leave it as it is. Since it's a wired nodes, location is not needed. So leave it as it is. Now we'll run it again. Map double F and run. Okay, so now it will be giving a warning here, because animation interface node does not have mobility model. So because the node is wired node, so it is not movable node. So you will get a warning. Don't worry. So the warning is there. Discard the warning. Now we check the file name first.xml. There is a file called as first.xml is created. Okay. So open this file. First.xml. You just open this file. So the file looks like this. Okay. So you may not understand anything. So we have to process this file using NetAnim. Okay. So now next I'll go to NetAnim. How to open NetAnim? How to open NetAnim? Again, so I'm just asking you to open a new terminal. Then go to cd ns all-in-one -3.31/ NetAnim just check it here. So NetAnim -3.108. Okay, so this is the way we'll use it. So NS all-in-one, (3.31/NetAnim). Then to open NetAnim, the command is /NetAnim. So N and A are in uppercase. Okay, so / indicates current directory. So as I already told you that one single dot indicates current directory. So / also indicates current directory. So dot or / indicates current directory. So within the current directory, there is a file called as NetAnim. So open this folder and we will go through this. Open it. So this is the window. So this is the NetAnim window. So once we have the NetAnim window, here in the top left, we have the animation window. So the file selection window. So select the file selection, go to the folder. We have first.xml. Okay, open. Now you can see. Maybe I'll just node size make it to 10. So there are two nodes. As we have seen, there are two nodes. The number of lines is 5. So now I'll run the simulation. So the fastest simulation slow. I'll adjust the knob to make the faster slow. So I'll go with slow simulation. Then start it. Now you can see the packet is being sent. You can see here 2 seconds. You can see 2 here. The packet is received. Then at 2, 3, 4, the packet will be second packet is sent. 2 packets are being sent. Then responding with 1 packet. So 2 packets sent. Okay, so 2048 bytes. Now after 3 seconds, after 3, another packet again will be 2 packets will be sent. You can see 2 packets, one after the other, because we have sent the maximum number of packets is 2. So that's why it is sending 2 packets. Now you will be getting 2 packets right from the server. So client to the server. So this is one simple network animation window. So this network animation window will show you how really your network is performing, or your whatever we have sent, how it is really performing well. So this is how the way this packet. Now you can see the statistics of the node. So we have only 2 nodes, node 0 and 1. If you want to know about node 0, so this is a node 0, IP address, MAC address, all these stuffs are there. And if you want node 1, we have all these informations are there in node 1. Okay, so we have node 0 and node 1, we have here, it's available. Okay, so this is a simple animation window, right? Now if you want to see the export table, so the transmission from which point to which point, so this, if you want to check, you can check it here. From ID to ID, what is the time duration? So these things you can check. So in case if you want download, you can download the export table. So you are having an option of export table. So table. You can download this. Okay. So later on, if you want to plot any characteristics using this, you can able to do the characteristics. So on what timing, if you want to print the timing axis, you just print it. And here 0 to 1, how it happens. There are 2 packets, so how the packet have happened. So this also you can check it. Okay. So this is on simple net animation. Okay. So NetAnim. And how to install this NetAnim, how to do that, you can able to refer my videos as well. So how to install this software into your machine. Okay, so this is on NetAnim. So now 3 things there. So one thing is source code, then animation, then logs, or we call it tracing. The 4th thing is plotting. So we need these 4 things in any research, in any networking research, we need 4 things. Source code. So source code is now done. So C++, first.cc, it's done. Animation, we have verified it. using a NetAnim. Now we are going to tracing. So there are two traces. Two traces are possible. One is Wireshark, and another is ASCII trace. So there are two things. So one is Wireshark, another is ASCII trace. So we will see both one by one. We will see. Okay. So first we will go with ASCII trace, which is very simple to implement. No external libraries needed. So we need ASCII trace as well as Wireshark. Wireshark also doesn't need any external library. Then finally we'll plot characteristics graphs. Okay, so now we'll go with ASCII trace. ASCII trace. We need a software called trace matrix. Okay, so we need a software called trace matrix, which needs Java to be installed. So we have installed that also. So trace matrix needs Java, that is also installed. Okay. So now I will be going through this third option. First stats. Okay. Now below this animation, so I will just do that. The following line is written by Pradeep Kumar. Okay. Now again, following ASCII trace written by Pradeep. So no external libraries, header files are needed. Because by default it comes. So ASCII trace helper. ASCII. So define the class ASCII trace helper. Okay, with an object ASCII. Okay, now ASCII, we want to check ASCII on a which in the channel. I want to check it on the channel. The channel variable name is point to point. Okay, copy this point to point. Because ASCII tracing, the tracing cannot be on the nodes. It should be only on the link. So that is on the channel between node 0 and node 1. So changing this point to point, taking this point to point, come here. Point to point dot enable ASCII all. So enable ASCII all means for all the parameters you enable ASCII, then ASCII dot create file stream. So to which file you want to send these values? I want to send it to first.tr. So I want to send the file to first.tr. Okay. So point to point is the name of the channel name. So enable ASCII all for all the ASCII enabled in the entire channel. So to which file it has to write? It has to write to the file called as first.tr. Right. So this is what I am going to write. Now after I change the modification, I need to run it again. So I need to run it again. Anyway, I'll just use this line. Include the following ASCII trace. Okay. So this we have to include in this. Right. So again, this for the simulator colon run function. Again, the following two lines has to be written before the simulator colon run function. Okay, right. So now what I do is I'll just go back here, go to NS 3.31 WAF double-hyphen run scratch first. Okay, so I'll be compiling it again. So I should not get any errors. Okay, so if you get error, you cannot see the output. Okay. Now clear it and check the ls. So we have a file called as first.tr. It is generated. So I'll open what is this contain. So this contains ASCII. So see the number of lines here is, you go to the last line. So the total number of lines is around 24 lines. You can see here the bottommost icon here. I'm just see the mouse cursor there. So line number 24. So in the line number 24, totally there are 24 lines. So the entire data is recorded here, but you cannot understand this record. So you can see this first line, plus means NQ, plus means NQ, minus means DQ. So putting into the Q is plus and removing from the Q is minus. Time is 2 seconds. Which node? The point to point, it's a transmission queue, NQ. That's what NQ. Then point to point header, point to point protocol header. The protocol number is 0x0021. That is a hexadecimal value. Likewise, it will be telling you the values, all this stuff. Okay, so what is the size of the packet? The size of the packet is 2056 bytes. Port number 491532, port number 1098. The payload fragment, what is the size? So likewise, each and every line, it has some information. So once you process it manually, you can do that. If you do not process manually, process it via trace matrix. Okay. So I will go to how to run trace matrix for reading the .tr file. Okay. So again, open a new terminal. Open a new terminal. Then cd trace matrix dot. So I don't know what is the output here. CD trace matrix hyphen 1.4.0. 1.4.0. So by the time when you download, you just check what is the trace matrix versions are available. Okay. So then Java space hyphen jar trace matrix dot jar. This is the command. So cd trace matrix hyphen 1.4.0 Java space hyphen jar trace matrix dot jar. Okay. So I'll just go here. So I already installed it. So Java space hyphen jar trace matrix dot. So this is the command. Then run it. Open it. So once you're opening it, the software opens it, and you'll get a plain screen like this. So in this plain screen, select file, choose file. So choose the file, go to NS all-in-one 3.31, NS 3.31, and first.tr. So I got the file first.tr, open it. After you open it, there are options like file attributes, read, write, and execute. So by default, execute analysis. Okay. So now you can check it. The total number of lines on the file is 24. As we have seen, there are 24 lines on this file. The number of enqueued packets is 8. Number of sent packets 8. Received packets 8. Dropped packet 0. Total time, simulation time is 3.01 seconds. Time of analysis 0 seconds. Now how many nodes are involved? So there are totally 2 nodes. About the nodes, you can form it. Then throughput and the good put. So what is a throughput and what is a good put? Okay. So for node number 0, what is the throughput, and node number 1, what is the good put? Okay. So then little result. So little result is number of packets sent per second. So that's what little results. And we have some quite good numbers here. Lambda, EFW, EFN, and EFW into lambda. So we have these numbers. So this is on Little's result. So you can check for what is meant by Little's theorem and Little's result. You can understand. Then streams. So in the streams here, so what are the different streams? That is UDP streaming. How it comes. So this is what the UDP streaming. Actually, this should be enabled, but it is not enabled. This button is not enabling. So it will be enabled only for TCP protocol. So export TCP graphics. Whenever we have TCP, automatically this button will be enabled. We can plot the graphs and characteristics. I'll show you that in future. So maybe tomorrow we will try this. Okay. So this is what the results. Now how can I plot these results? How can I plot this? Anyway, we have throughput of only 2 nodes. So the next example we'll see the more number of nodes, so that we can understand about the more number of nodes. So that time we can able to plan it. Okay. So Anyway, if you want to just copy paste, Control C, I will just use this value, Control C, then open graphics, Control V. Okay, so the values are pasted here. Then this LibreOffice, or if you have MS Office or Excel sheet, you can plot this. So this is on red color, node 0 and node 1, the two values, and these two on the good put, and this on throughput. So throughput is always higher than the good put. So what do you mean by throughput and good put is? So throughput is all layers. So good put is mainly on the application layer packets. All layer includes application layer, then transport and network layer. So this is the throughput, and good put means mainly at the application layer packets. So throughput will always be higher than the good put for a given set of values. So now we have plotted these characteristics. So in our case here, we have plotting also done. So logs we have done it, and plotting graphs. So what we have done is just only two nodes. So what else we can get? So we can get the same simple option here. So next thing is we have Wireshark. So this is one thing. The Wireshark is industry standard software for packet tracer. So Wireshark is an industry standard packet tracer, packet analyzer. So NS3 sends, creates PCAP files that is understandable by Wireshark. So we will see that also. So because I will be showing you all the examples here, so that any set of examples in future if you are trying, you can try all these methods in those examples. Okay. So now what I do, same thing, point to point. So point to point, enable PCAP all. So you can use enable PCAP all. So then I'll just open the other file. Okay. So no streaming, just directly put the name of the file and first. So point to point, enable PCAP all first. So this is the packet capture, Wireshark file. So I'm just using point to point dot enable PCAP all. Okay, now after changing, I need to run it again. So again go to NS all in one 3.31, then NS 3.31, then WAF _ run scratch first. Okay, so now when you check it, we have first 00 pickup and the first 10 pickup. So between 0 to 0 and 1 to 0, we have these two pickup. So to open this file, first -0 1-0 pickup, we'll use Wireshark. Open this like this. So Wireshark space. You can directly use Wireshark like this also. So using your command, you can use command line, or you can directly use Wireshark here. So whichever method you want, you can try that. So Wireshark first -1-0. Okay. Now this is what. So Wireshark shows you like this. So what time, what happens? Totally there are 8 packets, as we have seen 8 packets. So now this is very advantageous. It will show you the protocol. What are the protocols? So we have IP version 4 times and the UDP 4 times. Okay. So what is the length of this packet? Everything will be shown you here. Then if you want to see about UDP, select UDP and just see the packet structure. So what is the header? What is the internet protocol version? What is the P2P? What is the frame structure? So everything it will show you. Okay. So all these options it will be showing you here. So this is on packet capture, and we can see some of the graphs here, like IO graph. See the IO graph here. So this is the graph here. So at point number 4, the entire line is printed here. So this is an IO graph. Okay. So not only that, we have various statistics. So packet length, you can check the packet length. How many packets length? So mostly there are 1280 to 2559 4 packets, and 320 to 639 4 packets. So what is the average packet size, burst rate? So all the information about your packet structure will be shown here, and there are other statistics as well. So protocol hierarchy. So in what protocol hierarchy you are using this? So point to point, internet IP version 4, user datagram protocol, and data. So these are the different protocols that you can make use of. So you can able to analyze packet by packet thing and resolved addresses. So what are the resolved addresses that you have seen? So these things also can. Port number. So what port number you have used, that also you can able to check it. Then so IP version 4. So IP version 4 statistics, you can able to check the IP version 4. So at point number 2, how many packets? What is the rate at which it has transmitted? What is the percentage? What is the burst rate? And this information on each and every IP address of your machine. So this on first 1-0 PCAP. So this way we can able to find out. It is a very powerful software. Packet capture, Wireshark is a powerful software that you can make use of understanding about the minute level of your packets. So even the bit level also you can able to see if at all any encryption or decryption issues when you transmit a packet. To that level also it is possible to trace it or analyze it. So this is what Wireshark. So even for Wireshark, if you want to take a workshop, then we can take a 2-day full day workshop on Wireshark. But the advantage here is NS3 have the facility of sending your output as a PCAP. PCAP means packet capture. So here PCAP means it's a packet capture file. So it is a packet capture file for PCAP. Okay. So we'll close this. So we can able to do so many applications in a given simple example. Okay. So anyway, I'll just recap all these things so that when I move to the next example, you can understand. So in the first .cc file, we have included the following other softwares and methods. So what we have tried is number 1 is NetAnim for animation. Number 2 is ASCII trace using trace matrix. And number 3 is PCAP. So PCAP trace using Wireshark. So this is what we have. And one more thing is pending. Anyway, I don't know whether I have time to do this. So we have something called a flow monitor, which we can able to find out packet loss, drop, jitter. These data we can able to find out using the flow monitor. But slightly flow monitor is tedious in handling that because we need processing of this particular XML file. So anyhow, if time permits, I'll just show you. Else I will leave out this flow monitor. So in this example, we have seen up till this we have seen. So totally 3 things we have made the modification. So one is animation, then tracing, then Wireshark. Okay, and even we have plotted also throughput. We have plotted throughput and goodput. So in case if you have any queries or any as of now, if you have any queries or anything, So maybe you can put it on your chat window, so that, or else you can always understand you. Always you can understand at later point of time also, and then you can. So in case if you want to refer, I have my YouTube channel in the name of Engineering Clinic at this location. /TS Pradeep Kumar. So my channel. So whatever I teach you now, whatever I am just handling now, everything is available in this particular channel. So all over and above this, there are so many things, or other things also there. You can refer. So in case if you have any queries, any doubts, if you bring it tomorrow also, it will be well and good. Okay. Shall I move to the next example? I think. So next example is okay. Okay. So I'll move to the next example. I'll close this first.cc here. I'll open second.cc. So you can see now second.cc looks like this. So you can see here second.cc is looking like this. Okay. So there is no other way other than informing everything. One minute. Just searching for the pen. Yeah. Okay. So this is the simple example that we can do in second.cc file. So this is slightly complex, and the third.cc file is still more complex. This is using wireless. So I think I can go with second.cc. So later on I will go with third.cc, or else directly I can go with third.cc. So third.cc file is complex like this. Anyway, I'll go with third.cc rather than second. So because else I have another 1 hour time. So I'll go with third.cc. Okay. So now in this, just see that here node 0, N0, N1, N2, N3, N4, and these two are Wi-Fi, N5, N6, N7. Okay. We'll go with this. So now what I'm going to do is, so we have so this is 0, node number 1. So this here is P2P, point to point. Okay. Now so we have a LAN. So we have a LAN cable like this. So in the LAN, this one is connected, node 2 is connected, node 3 is connected, and node 4 is connected. So we call this as CSMA. So this is carrier sense multiple access. Okay. Now this will be an access point. Okay, access point, that is AP, whereas this is node number 0. Okay, now you can see, and then we have other nodes. Wi-Fi nodes, so we call this as 5, 6 and 7. So these nodes can move. So these nodes can move because they have mobility model. So because of mobility model, these nodes can move. So this is a CSMA. So this is on bus. Okay, so this is on bus protocol and this Wi-Fi. Okay, now here this is an access point. So AP means access point. So now this is what the design of my network. Now in this design, how can I go to set my nodes, or how can I go to simulate this particular network? So please remember, please understand some of the code you might be already know. It was mentioned in first.cc. Now we are coming to third.cc. Okay, so IP address is given here 10.1.3, 10.1.1, 10.1.2. So what we'll do is, so we'll change the IP address according to our need. So what I do here is 200. I have given 200.10.24.0. I'll give this. Then 200.10.25.0. I'll give this. And here this will be 200.10.26.0. I'll give this. Okay, so my IP address here, this IP address here, and this IP address here. So these three ranges I will give. Okay, so this is my first design. So whenever you write any coding, whenever you understand any coding, so please understand the network first. Later on, you can understand the code in an easier way. So that is the first step in this point. So understand the network. Later on, you understand the code. If you directly open the code, you may not understand anything. Okay, so first you understand this. Now we have to find out what is the server, who is the server, and who is the client. All these things. So we'll see in the code. Right. Now we'll just go through the example. So we have this verbose mode is true. I'll just show you what is this verbose mode. So we have unsigned integer 32 bits NCSMA. NCSMA means number of CSMA nodes is 3 by given 3, and number of Wi-Fi nodes is again 3. So 3 number of Wi-Fi nodes and 3 number of CSMA nodes. CSMA means carrier sense multiple access, and Wi-Fi means there's a wireless nodes. Okay, so totally there are 3. So please remember that 3 means these 3. So these 3 refers, this 3 node refers N Wi-Fi, the variable name N Wi-Fi, and these 3 nodes refers N CSM. Okay, so we have this logic here. So these 3 nodes, because these 2 nodes 0 and 1, they belong to P2P nodes. So okay, so that's how. So N CSMA is 3, N Wi-Fi is 3. Okay, then how many nodes we can able to plan? So N CSMA is 3, N Wi-Fi, and verbose mode is true here, and tracing is false here. So by default tracing is false. So whenever you want to enable, you can enable true there. So tracing equal to true if you want to enable tracing. Right. Now we'll go to the question here. Okay. Now there are some logic here. If number of Wi-Fi nodes is more than 18, then it should be telling you that Wi-Fi should be 18 or less. Otherwise, grid layout exceeds the bounding box. So that means within a particular bounding box, you cannot have more than 18 nodes. So that logic you just build it here, so that you cannot give more than 18 in a given grid layout. So because Wi-Fi nodes has to be sit in a wireless fashion, so you cannot have multiple nodes in a particular given area. So that's what the restriction here. Okay. Now here also we are going to use UDP echo plane in echo server application. So now in this case we have the node container P2P nodes. So earlier in the example we were using simply nodes variable. Now we are using P2P nodes. So please remember the variable names and the letters what they use, because we will be using these details for the further use. So P2P, P small letter and N in uppercase letter, that is P2P. So how many P2P nodes? Totally there are two P2P nodes. So N0 and N1. Okay, so I'll write it there. N0 and N1 are the two P2P nodes. Fine. So then the P2P, the data rate is 5,2. So 5 Mbps and 2 milliseconds. So as we have seen in the previous example, the value here is 5 Mbps and 2 milliseconds. Okay. The net device container P2P devices. P2P devices equal to point-to-point or install and P2P nodes. So on the P2P nodes, install the net devices. Okay, so then that's what. Now CSMA nodes. So how many CSMA nodes? So already we have one of the node common with it. Now CSMA nodes is, the first node is P2P nodes of get of 1 and CSMA nodes are create N CSMA. So this is actually the equivalent to CSMA nodes dot create of 3. That means this is what. So that means that create 3 nodes. So create 3 nodes. Already the value 3, we know that NCSM is 3. So we are going to create 3 nodes. The first node is P2P nodes are get of 1. Okay. So now we have totally CSMA nodes refers to 4 nodes. Okay. So now I'll just write down one statement. CSMA nodes dot get of 0 is equal to P2P nodes dot get of 1. So this is what agreement. So the node number 1 is referred by CSMA nodes dot get 0, which can also be referred by P2P nodes dot get 1. Okay, so this is the statement, because this is the first node which is been added there. Similarly, I'll come back to that. Okay, now CSMA helper, CSMA channel attribute is 100 Mbps because it is on a bus protocol. So it is on bus, so totally 100 Mbps and 6560 nanoseconds. That means 6.56 microseconds. So that's on nanoseconds. So I mean this thing. So here we have point to point. Here we have 5,2. That's what, 2 milliseconds. Then 5 Mbps. So this is what here. But here, whereas here in this case we have 100 Mbps, then 6560 nanoseconds. So in case if you want to convert into microseconds, then you can use 6.56 microseconds. Okay, so this what the Wi-Fi we'll see. Okay, so point to point and the CSMA. So now this is done. Now install the net device on the CSMA device, CSMA nodes. So now CSMA nodes means there are 4 nodes. There are 4 nodes. Node N1 will have 2 net devices, namely one for P2P and another for CSMA. Okay, so N1 node N1 will be having 2 net devices, namely one for P2P, another for CSMA. Okay. Now next thing is we have this Wi-Fi settings. It is slightly complex. Okay. Now we will have this Wi-Fi. So just Wi-Fi. We have Wi-Fi 2 different nodes. One is Wi-Fi stationed nodes, okay, and Wi-Fi AP nodes. So there are two settings, so Wi-Fi station nodes and Wi-Fi AP nodes. So node container Wi-Fi stationed nodes, so create n Wi-Fi. So n Wi-Fi is equivalent to 3. So 3 is total number of nodes is 3, and first node is P2P node dot get 3. Okay, so this is the first node. Okay, so now what I mean here is Wi-Fi stationed nodes. So here it is create n5 totally 3 nodes, and the AP node is called as get 0. P2P nodes dot get 0. So Wi-Fi AP node is also called as P2P nodes dot get 0, because in access point usually the input is wired and the output is wireless. So this is what happening in Wi-Fi. So the input is wired and the output is wireless, generally in the access point nodes. So generally in your home-based router, so if you have a router in your home, so what happens is the router, the input will be on a Ethernet platform, whereas the output will be on a Wi-Fi. So output is Wi-Fi, input is Ethernet. Either it can be fiber or it could be any power over Ethernet, PoE or a simple Ethernet. Okay, so here also similarly we have this. So that's what here we have this access point. The input here is the P2P, the wired thing, and the output is completely wireless. So okay, now we have this Wi-Fi channel helper. So we have YANS Wi-Fi. So YANS means yet another network simulator. This is called as YANS. So YANS means yet another network simulator. So we have channel properties, we have physical layer properties, and we have Wi-Fi managers. So we have so many other options for a Wi-Fi network. So all these things we have to deploy. So first we are enabling the channel. So what kind of channel we want to give? So that's what the channel name here. YANS Wi-Fi channel helper default parameters. I am just setting a default parameter here. In case if you are from electronics background, if you want to do something on the communication aspect of it, then you can go through the channel properties. Like you want is the gain of the antenna, what type of antenna you are going to use, what is the L factor you are going to use, what is the frequency. So all these things you can adjust, and the transmission power. So all these values you can adjust when you set the channel parameters. But if you are from a computer science background, you don't bother about the communication parameters. You just bother only about the network. So in that case, you need not bother. So NS3 have a facility of setting all the default parameters. So that's what here default. Then we have a physical layer. So channel physical layer. Okay. So that also we have a default. Then create a channel. Okay. So create a channel. So set channel, create a channel. So creating a channel name. So then Wi-Fi helper Wi-Fi. So we have a Wi-Fi helper Wi-Fi, and we have a Wi-Fi manager. So NS3 supports multiple Wi-Fi managers. Multiple Wi-Fi managers NS3 supports. So you can refer many Wi-Fi managers. So you can do a project also there. So your project can be done on comparing multiple Wi-Fi managers. This also can be done as one of a project. So maybe I'll just show you the source code also for how many Wi-Fi managers are there. Okay, so now let me use something here in wireless network. In wireless network, maybe you might have learned in NS2 itself. So for setting one Wi-Fi, what you need is we need to set channel layer, that is link layer, interface queue, then energy if at all. Number 6 is location of the nodes, like x comma y comma z. Then number 7 is protocol. Number 8 is addressing. Number 9 is wireless managers. Number 10 is mobility model. 11 is any grid-based uh, location models like this. Then 12 is propagation model or propagation loss model. So these are the things you have to set in the wireless network. So wired network, there is nothing as such. Only you need to specify two things: the bandwidth and the delay. In wired, in wireless, you have to set all these metrics. Okay. So in this example, let's see what all the things they have set it. Okay. So now the remote station manager. So they have set a ARF Wi-Fi manager. So this is a Wi-Fi manager. It has been set in the Wi-Fi helper. Now next thing is a MAC. Oh, I forgot. So here this 13th is medium access control. So usually we call IEEE 802.11 A, B, G, H, J, N, AC, AX, then Wi-Fi 6, etc. So all these things we have to take care of it. So medium access control. Okay. So MAC is being set here. So the name of the MAC, what is a MAC we have to set, and there are two different MACs. One for the stationed Wi-Fi, another for the AP Wi-Fi. So we have to set two different medium access control, because stationed Wi-Fi means everything is wireless, whereas AP Wi-Fi is the output is wireless, the input is wired. So we have to set the two different MACs. So SSID means the Wi-Fi signal here. So now we can see my Wi-Fi signal here. So you can see my Wi-Fi signal here. So these are all called as SSID. These are all called as SSID. So Spoofy packets, HomeNet, Geo Wi-Fi, Joel's, Kumar's, and these are all some of the Wi-Fi signals here. These are all called as SSIDs. Okay. So this SSID in software, how do we emulate it? The name of the SSID is NS3-SSID. Then that will be given for active probing. So active probing means the stationed nodes keep on probing the server, so or the router. So active probing means, so they just keep on probing the network, the router. So if the active probing is true, means they keep on probing. If it is false, means there is no active probing. So that's what here active probing. But in the AP Wi-Fi MAC, the MAC is no active probing, because the server is always probing. So we need not mention active probing. Only for the client we need to mention active probing is needed or not. Okay. So that means what? When you bring your Wi-Fi device into a particular near the router, automatically it will be selected. But when you refresh it, the Wi-Fi, when you refresh, then it becomes passive probing. That is, active probing is false. Okay. So now we have installed the stationary devices, install PHY, MAC, and Wi-Fi station nodes. So we install the physical layer and the MAC layer on the Wi-Fi station. Similarly, here AP Wi-Fi MAC. So we have an access point, we have a separate Wi-Fi MAC, and we have the stationed Wi-Fi MAC, we have separate. So both are being installed in AP node and the stationed nodes. So once it is done, we go for a mobility model. So mobility model. So what kind of mobility model we want? So we have a position allocator as well as a mobility model. So position allocator means in what locations this nodes will be moving. The Wi-Fi nodes will be moving in what directions. So for that we have 510. So this is what the grid position allocator. So it is something like a grid. So based on the grid, the nodes are allocated. So usually it is on a row first model. Okay. So row grid position allocator. So delta X 5 and delta Y 10. So how it looks like, I'll just show you that. So one example here is, so grid position allocator means, so in the X axis it is 5, the Y axis it is 10. So on this grid only, this is a grid position allocator. Okay, so this is the grid position allocated. So you'll get a grid like this. So the nodes will be always in the grid. So on a 5x10 basis. Okay, so this is what the grid position allocator. So the value here is, you can see the value here is where it is. Yeah, the value here is 0, 0, 5, 10. So minimum x is 0, minimum y is 0, delta x is 5, delta y is 10. And grid width is 3. So 3 is a grid width. Okay. Then random walk two-dimensional mobility model. So random walk two-dimensional mobility model means the nodes will be moving on a 2D model. So 2D model means, so let's say if this is a 2D model, the nodes will be moving here, and it will move like this, and it will move like this. So like this it will move. So nodes will be moving in a slight movement like this, like this, like this, like this. So this is what the mobility model. So in this mobility model, we have the rectangle of minus 50, 50, minus 50, 50. So a simple small location within the area, the node will be moving here and there. So that's what here the mobility model. Again, we have multiple mobility models. NS3 supports many mobility models. So even you can do a project also in mobility models. Okay, but this is only for the Wi-Fi stationed nodes. So because Wi-Fi station nodes need the mobility model because they are moving. But AP node, they don't move. So they have a mobility model called as constant position mobility model. So AP nodes will have a constant position mobility model. Okay. So then we install the internet stack helper on the CSMA nodes, Wi-Fi AP node, and Wi-Fi station nodes. So we install all the three things. Then in the address value here, IP version address. So I just in the P2P devices we have 200.10. What I showed you, it is 26 point, sorry, 25.0. So I want to give 25.0, and here in this case CSMA we have 200 10 24.0, and here it will be 26.0, 10 and 200. Okay, so then I assign all the addresses to all these three bases. So like P2P, CSMA, and station and AP devices. So after it is done, the port number UDP echo server helper. So let me use the port number 1098 as I used always. Is 1098. Now please remember, now this is the server. Who is the server? It is CSMA nodes dot get of NCSMA is 3. So this is the server. So in our case, who is CSMA node dot get 3? So CSMA node of get 0, get 1, get 2, get 3. So node number 4 is the server. So this node is the server. This is the server node. Then who will be the client? Okay. So now the server is running with 1.0, 10.0. Now the client. So client again, one packet, instead of one packet, I will make 3 packets. Then I'll give 2048 things. Then here, this is the server. Who is the client? Who is the client? It is Wi-Fi star nodes dot get of n5 is 3. 3 minus 1 is 2. So this is the server. So stationed nodes 0, 1, 2. So we'll go stationed nodes of 0 will be this, 1 will be this, 2 will be this. So this will be the node number 7 will be the server. Client, sorry. So this is the client. Okay, node number 7 is the client. Okay. Okay, fine. So now node number 7. So here it will be, I will give the name as N7. And here the server will be N1, 2, 3, N1, 2, 3, 4, N4. Okay, N4 is the server and N7 is the client. So now next thing is This is a topology helper. Because they use the populate routing tables. That's a function. If you don't want to have a routing to be handled by any protocol, if you want to have a generalized routing, then you can use the IP version for global routing. So using that, we have a function called as populate routing tables. For each and every node, the routing table will be populated automatically by this class. Okay. So now simulator 10, and if you want to enable pcap, a tracing equal to true. But tracing is false there, but if you want to enable, you can make it true. Okay. Now I will run this example. So just a very long description, but anyhow, I may be a little bit fast because I thought of completing. I have another 20-25 minutes, so that's why. Maybe I'll just run this example now with all the things what I have done earlier. So like network animation, then trace metrics, then Wireshark. I will do that. I'll give the name it as third. Okay. So now I'll be running this example. Path double hyphen run patch third, no extension, simply third. Okay, so port number 9. So in the client side, I didn't change the port number 9. That's why I'm getting this value. So in the client side, yeah, here 1098. I need to put 1098. Okay, so I got 3 packets. So I just getting 3 results. So 2 to 4 at 4 time minutes, the things are running. Okay, now what I do is instead of 3, I'll make it 10 packets. So let's see 10 packets. What's the timing comes? So it is on 10 packets. Yeah, so totally 10 packets. So the timing ends by 9 seconds or something like this. Okay. So now I'll be checking the animation. So first thing is on the animation. So anything we have to do before this run function. Okay. So NetAnim module. I'll share all the source code. So whatever I do, in case you want it, I will share everything to the organizers. Animation interface. Anim inside bracket third.xml file. So this is the file name. We have to include a header file. So okay, so hash include within double quotes ns3 slash netanim hyphen module dot hash. Okay, so this is the netanim. Now no need of mentioning any other nodes. Let us see. So only third.xml is there. Now run it. Yeah, so some nodes need mobility model. So anyway, this warning, you discard the warning, so no need of capturing the warning, just discard it. Now you check the file, third.xml is there. So we have created third.xml file. So the third.xml file is created. Now we have to run this file. Okay, so to run this, what we do is go to netanim dot slash netanim, open third.xml file. Yeah. Okay, so now I'll make all the nodes to make it bigger. Okay, so now you can see all the nodes. So 567, node number 567, you can see they are the wireless nodes, and node 0 to 1, that is on the 234 on a bus, that is CSMA, and 0 and 1 on a point to point. Okay, so now I'll run the simulation. Pass. Now we can see there's a movement of 567. You can able to check the movement. Maybe I'll just make the simulation faster. You can see the nodes are moving. Okay, so see that how the packets are exchanging. Still only 2 seconds is over because the total simulation lasts up to 9 seconds. As per the output, it is up to 9 seconds. I'll still make faster. The simulator will make faster. So now we can see it is in a faster rate. Okay, now I pass it. Now see the position of the wireless nodes 567. They have just moved the different location at the end of the simulation. So other nodes they are stationary, so they are just staying at the same location because they are on wired network. But the 567 nodes are in wireless network. So in this also you can see the packets, so you can get to know about the transmission parameter. So how much transmission we can use it. So what we do is we can able to copy this. So copy this, then go to LibreOffice, Control N, Control V. They copied only a little bit. So it is in the table. So this is what the value what we got. So 0 to 5, 0 to 6, 0 to 7, 6 to 5. So across various values. So what is the transmission factor? So that is the TX value. So from ID to ID and TX and meta. So we can able to plot the characteristics as well. From node 0 to node 5. Okay. We will plot it. Maybe tomorrow I will just show you how to plot this using GNU plot. Okay. So then this is all about the network animation, NetAnim. Now, in case we want to use the ASCII trace matrix, ASCII trace helper, ASCII, and then we have 3 channels here. So because in the first example we have only 1 channel, in here we have 3 channel. I'll see the name of the channel name, variable names. So the variable name here is one thing is not PHY. So PHY is 1, then CSMA is 1, and one more thing is point to point. So there are 3 things, point to point. So what I do is I'll just go to this option here, CSMA dot PHY dot. So I will create like this, then enable ASCII all, then ASCII dot create file stream. Then I use, for example, p2p.tr. I use a file name p2p.tr. I'll just copy from here to here. So here I'll use csma.tr. Then I use here phy.tr. So 1 dot. So now I will be running this example again. Third. Okay. So now we can see the trace files. So p2p.tr, php.tr, and csma.tr. We got all these things. So to run this in trace matrix. I'll go to trace matrix. So cd trace matrix and java hyphen jar trace matrix. In this file open, let me go with the Wi-Fi first. So Wi-Fi have multiple files. So I'll go with php, sorry, phy.tr. I'll go with this. Okay, there is some error. So anyway, I'll just go with this CSMA. So in the CSMA, we have 4 nodes. About the 4 node details and throughput. We have throughput, goodput, and other stuff. So we have for the node 2 and 3, there is no goodput or throughput because via the node 2 and 3, nothing happened. Only node 1 and 4 were involved in the exchange of packets. Then details result, then streams. So in UDP, you have all the streams available. So this is on CSMA. Similarly, P2P. So you can able to plot the characteristics as well. So I don't know why PHP is not coming. Okay, some error is there in phy.tr. Enable ASCII all. Okay, fine. So this is on third. So we have P2P, we have CSMA, and we have PHY. So PHY alone, anyway, I'll just run one more time. So the number of lines is, let's see. So total number of lines is 667. You can see that there are total number of lines is 667. Anyway, we'll just check with this. Now I'll be running it. Okay, there is something called as a get Wi-Fi MAC length. Some null pointer exception. Anyway, I'll just rectify what was that. So then one more thing here is NS all-in-one, NS 3.31, then Scratch, then third.cc. So in this, in the first beginning, we have tracing equal to false. I'll make it as true. So once I make tracing equal to true, then in the last logic, as per the source code, it will generate these files, the packet capture files. So you will get multiple files on these 3 devices. So one is P2 point to point, another is PHY, another is CSMA. So in the AP device, we are getting PHY on the AP device. So that also we can calculate. So now instead of 10 packets, I will make it 3 packets. I'll just show you that. 3 packets, then I will run it. Okay, only 3 packets, and so we can see third dot pcap packet capture file, it is generated. So third 10 like this, the packets are generated. So second, third. So in Wireshark, I can check it. Wireshark third -1 third pcap. So you can see that I have so many packets here: ARP protocol, address resolution, IPv4 for UDP. So like that, we have so many packets here. So there are multiple packets will be generating here based on the Wi-Fi access points and the CSMA and the P2P. Okay. So maybe you can refer some IO statistics, IO graph. Yeah, you can see the IO graph, how the IO graph looks like. It is on a decreasing pattern. Okay. And in case you want to use all access points, so all values, so remove everything. So don't give enable pcap. You can enable pcap all. So you can use ALL also. Once you do this, we'll run it example one more time. We'll run it.
Hello, Pradeep sir.
Yes, sir. Yes, Guru.
We can wind up now because the streaming will stop by 4:50.
Okay, fine. Okay,
Okay.
friends. So what you can do is just practice it. I'll just share the source code, everything to you, to the concerned team member, so you can refer all these steps, and then you can. So in case if you want to practice NS3 using a virtual machine, so you can download from my YouTube channel. So maybe just one fine minute. So I have a channel here. This is my channel, Engineering Clinic here. So you go to my videos. So in the videos here, I have 1 minute. Let me go see it. First tester. Yeah. So we have a VM image, so you can download.
Costa is selected to play the role of Jhansi ki Rani. Very good. Okay, Google, tell me about Rani Lakshmibai. She was one of the prominent figures of the Indian rebellion of 1850.
So I'll just paste it here. So I have, oh sorry.
Hi learners, welcome.
So I have given a complete OS also here. So in case you need a OS, you can download this link. So this link is you can download around 4.56 GB. So it's my own OS. The password also there 123456. If you download your password, that also will be there. So this is the link file. So you can download the complete OS. It has NS3 by default installed. So you can refer through this Ubuntu 18.04. So thank you for your time. Thank you, Guru.
Pradeep, thank you so much for your wonderful session today. Participants, we have Pradeep will be handing the second session tomorrow from 2 o'clock. So please kindly attend the session and make use of it. If you have any questions, you can post your questions in the chat box, and he's going to address all the questions in the chat box. Okay. Thank you, Pradeep. Thank you for your valuable time and wonderful session. It was really good. We'll meet you
Yeah,
tomorrow
thank you.
exactly by 2 o'clock. Thank you.
Yeah,
Thank you so
okay, Guru.
much.
Thank